Welcome to SmartGym. In this video we will show you our application, the technology we have adopted and the repository, and we provide also a short interactive demo. So let's start. In this slide it's possible to see the enabling technology of our application. In particular the SmartGym catalog, which has been developed from scratch, and the device connector, which represent the middleware of our application. This means that we can plug whatever sensor in our device connector, and the middleware it's enabled to expose these resources as well as possible services coming from applications in the middleware. Indeed, our SmartGym core application communicates with the catalog in order to register its services, search for resources, and so on and so forth. Those services exposed by the SmartGym core application, which is built using the microservices approach in order to avoid the monolithic app, can be then used by more customer-oriented applications such as the web application and the Android application. At the end, we have this connection with the DB, which is a MySQL database, and we use Mosquito Broker for publish and subscribe topic, mainly for the sensor data. This slide shows additional technology that have been used for the application. Starting from this peak and the Telegram bot, we have used Splunk for searching and visualize data in dashboards, and also we have used Nose for the testing part of the application. Now we move to our repository in GitHub. We want to show the code, the different specifications that we have written for the repository, as well as the way we have used Git for a more collaborative environment and version control. This is our repository in GitHub. As you can see, there is a small description of the project, as well as some folders that we'll discuss later. As I mentioned, we have used GitHub for a more collaborative environment. Indeed, as you can see, there are many commits, and as well we used issue to manage the different problematics of the code. Also, we have used the project section of GitHub to manage the different parts of our application. In this case, we can use the Kanban approach to organize all the work. As you can see here, it's possible to see the different parts, the to-do, the progress, and the done task that have been completed for this particular part, in this case Splunk. Let's go back to the main repository. We have the backend written in Python, which enables all the communication between sensor and the SmartGym catalog and the application. And also we have the mobile application written in Java and the web application written in PHP with the front end in HTML. And now let's focus on the backend of the SmartGym application, starting from the documentation. Here we can see that we have different folders which more or less try to reassemble the structure of the main repository. In each one we can have detailed information about the code we have written. But I would like to start with the middleware specification. Here we have the SmartGym middleware specification. The first thing we want to do is then to try to define the actor of our system. We have the device connector, is where we can plug new IoT sensors, and our catalog, which is composed by a service and resource catalog. Together they form the middleware of our application. This means that we can deploy a sensor, and those sensors, or better resources, are available for all applications in the middleware. So, the big picture. We have the middleware, gym catalog and device connector, then we have the application, the one developed using microservice design technique, and then we have sensor actuator. Here it's possible to see the communication protocol between microservices and catalog. This is a very important part because each microservices that enter in the middleware has to communicate with the catalog in order to register and then to acquire the services and resource it needs. But let's get step by step. So we have the entry request of the microservices towards the catalog. In this case, we start a sort of session. We keep information of the microservice that register in the catalog, and so we have a stateful communication between the two. Then the response upon a request of not only to register, but also of configuration settings, comprise so the configuration settings itself that are needed by the microservices. Configuration settings are, for example, the DB credential, some parameter to be set up, and so on and so forth. Then the microservice can request the services and resources it needs. This is crucial because the microservices may require those for working properly, so it also can wait for having the required amount of resources and services in order to start. And once it has these resources and services, it can register its own services to the catalog. Be careful because we don't have resource registration for the microservice. In that case, is the device connector, but we will see it later. Everything is enabled with REST API. So another problem was that we needed a unique identifier for resources and services in the middleware. In this case, we can have microservices that have local ID or local, let's say, qualifier for their resources. In that case, services, or in the case of the device connector, we have resources, local URI for the resources. When the communication starts with the catalog, we register those resources, and the catalog tries to compose information about host ID and the local URI or local service ID in order to provide a full qualified domain name. In this way, we are sure that service and resource are uniquely identified in our middleware. We have also information about, we can see information about service catalog, so the different part and the way that how services are exposed by the application and how are saved in the catalog. As well, we have the same for the resources. In the case of the device connector, it registers resources, and it registers resources with a given structure in JSON. So everything is defined and must fulfill these requirements. Here we have the documentation about the microservice and the instances of our microservices. Start with the microservice. Here's how we use the microservice class. Indeed, we have created a base class that other classes can extend in order to customize its own application logic. So we have an initialization part. The initialization part is already built in and provide all the communication part with the catalog, so it's test, it works. So when you have to then extend the class, you just need to provide some additional tuning and the application logic itself for the microservice. We have also a failsafe method. If you want to raise exception, you can also launch this failsafe method in order to disconnect from the catalog. We have possibility to interact with the DB, and as well the microservice enable both an MQTT part, communication part, and a RESTful part. So as you can see here, we have also REST API. The application logic, it's a method that has to be implemented, and there the developer can then provide the logic of the application, so do all the operation it needs, retrieve the configuration setting from the received from the catalog. Another important thing I forgot to mention is that each microservice, also the device connector, we will see when loads, so during the initialization part, it loads a configuration file. Configuration file is important because it provides all the information and all the requirements that the microservice needs. So it comprises also the services he has to require to the resource catalog, service catalog, sorry, and also as well as the resources to the resource catalog. And in addition, all the service that the microservice exposed to the catalog. So everything it's in the configuration file, and it's loaded during the initialization. This is a very crucial part of the microservice. Okay, let's go back to the microservice documentation. We have also a MD file about microservice instances. Those are the instances created extending the base microservice class that we will see later. For now, just focus and try to describe. We would like to describe how the application is made. So what is SmartGym core, SmartGym application? So it's a bunch of microservices that we can divide in 4 main parts. One part, we called it inside customer-oriented services, that are all the services provided in the gym. So high access control, exercise interaction, facility manager, all those parts that interact with the facility and try to, let's say, provide services for the customer in the gym and also for the owner of the gym. Then we have off-site customer-oriented services. These are not really off-site, but are meant to be then carried by the user during its experiences in both in-gym and out of the gym. So we have the Customer Account Manager web and the Customer Manager mobile application. Then we have gym-oriented services, which are services for the facility itself in terms of gym. So the ambient control strategy, for example, and real-time statistic analysis, which is a module that collects data from the sensor and provides statistics, which can be useful for the owner of the gym. Here we have a very in-depth description of all the parts with the configuration settings, requirement or not of DB access, if has published and subscribed MQTT topics, and so on and so forth. So you can have a look on this file to have a very more in-depth overview of our application and the different microservices that enable our application. But for now, just keep in mind the different parts, the different microservices that we have enabled in order to have an idea of what the application does. Now let's see the microservice-based class implementation. So let's go to microservice. Here we have all the instances, we have the README, which is how to use the microservice. It's the same that we have seen before. Then we have this customer account base, that it's the base class for the device, the mobile application and the web application. And then we have our microservice base class. Let's see this before the others. So here we have our microservice object. This class is meant to be taken by the developer and then used to instantiate, so to extend this class and create other classes, customer microservices. Indeed, the base class allows for set up all the communication part with the catalog, so it's already tested, it's already built in here. So the application automatically performs everything, but it does thanks to the load configuration settings method here. So this method allows to load, we can see it. It allows to load the configuration setting and then set all the value it needs. Device ID, host IP, server port, configuration settings, and so on and so forth. So it needs configuration settings by the catalog and so on and so forth. The exposed service and so on. So let's go back here. So we have then the catalog registration process. We can search it again. Catalog registration process. So everything that I've described before, it's here, it's implemented, and we can see also that we have logging, but we will discuss it later. There are error checks, so everything is checked. It needs to be compliant with the communication protocols we have defined with the JSON. Everything is checked, so it's very resilient in this point of view. Okay, then we have the request services and resources, and also for those for example, for the services we wait for having at least one available required service in the middleware. If none is available, the microservice waits until this instead is available, and we can see here required service, for example. And here indeed there is a cycle, and we cycle until the current service category is not there is a minimum amount of service, which is typically it's one. We need at least one service available in order to run the microservice. So everything here, it's meant to enable the communication and set up the microservice. It's the warm-up, we can say. Then we have a set of methods that can be used by the developer for its application logic. For example, the DB connection. Provide all the methods for connecting with the DB and retrieve the data from the DB, performing query, and we have also prepared statements, so secure statements, secure DB requests. Then we have the MQTT part. As well, here we can initialize and start the microservice MQTT client. We have possibility to publish and subscribe. We have possibility to set the callbacks and so on and so forth. Everything is provided to the developer in order to take this class and develop its own microservice. We have our MQTT on connect service, as you can see, and so on and so forth. And then finally, we have the REST API part, so we can expose API using get, post, and put, and so on, and delete using CherryPy. Again, this is a part, as I said, the microservice can expose API, so expose services, or it can simply subscribe to topics, takes the data, elaborate stuff, and use the MQTT part to send other data, activate actuator, and so on. So depending on the role of the microservice, we can decide to do different things. For example, the device, the area access control the access to the gym facility. It doesn't require to expose API in that case, but for example, the mobile application, in that case, we have a microservice dedicated for exposing API towards our mobile application. And so on, we can see we have the methods. And this is very important. We have the methods for starting the microservice in server mode or either in here we have instead the instances of our microservice. So we took our microservice based implementation and we extended it for the different part of our application that we have discussed above. Indeed, we have the same microservice instance MD file here as a README. We have the ambient control strategy, which actually controls the temperature, humidity, and so on. For example, we can see this very quickly as the implementation of the microservice class. So we just init it, we set the configuration. This has to be override because depending on the microservice, we can require different kind of configuration setting to the catalog. In this case, for example, we require a very large number of configuration parameters for the humidity, temperature, and so on and so forth, as well as the DB, as I mentioned before. So we have also, these are custom defined methods to help in the just to enable the code in the application logic. We have presence, temperature callback, humidity callback. Those are all the callbacks that then are plugged in the MQTT add callback function that is already available. So the developer has only to define those callbacks, define the topic, the subtopic where it wants to be subscribed, and then put the callback here. So very simple, few line of code, everything is provided by the microservice, but in that case we have something a microservice that communicates with the catalog, take all the resources it needs, all the configuration, and then provide some execution control over the ambient and the sensor deployed in our which are present in the middleware. Now let's see the device connector, which is another important part of our application, SmartGym application. So the device connector under the hood is a microservice, but with a difference. It exposes resources. And so for this we have enabled topics. We can be publish and subscribe, so publish and subscribe topics using MQTT. In that way, the device connector, we can plug sensors expose those resources using MQTT, and other services in the middleware can access those resources, asking them to the catalog and retrieving them using MQTT directly. So they can retrieve the status or activate actuators using this specific topic struct hierarchy that we have defined. Then we have the publish message. More in detail, the publish message, so the MQTT publish and subscribe are based on a data format which is well defined. It's a SNML plus JSON. We have slightly modified it in the term that we just decide to put the base stuff, the base name, base time, base unit outside of the list of events. But we will discuss in a moment. So we have this is retrieved from the specification. We have the name, the unit, the value. So in the case, the name of the resource, the unit of the value of that resource. Or we can also send Boolean value or string value and the timestamp. This is a representation of base value. As you can see here, we have a list of events. Call it events. We have also a class that can model this kind of stuff, as well as the JSON ML itself. And here we have this base name and stuff, and we have put this outside. So we have slightly changed, but the idea is to use send. Now let's move to the implementation of the device connector just to have a look. As I said, this is a microservice, but we have slightly different change, because we expose resources. So we have this register resource here, which is not present in the case of the base microservice, so we have to implement it here. Then we don't have set configuration setting to set up. We can load the exposed resource. This means that we take the configuration settings, we parse it a little bit in order to include the device ID, and then we send them to the catalog. And then we have all the actuator the actuator callbacks. In this case, we set the callback for the actuators, and then the action in the case, for example, we receive an MQTT message in order to activate the gate, the locker, or set the equipment, turn on the light, activate the shower, and so on and so forth. Here we have the class method to start the microservice in a normal mode, and the application logic, which just perform initialization of the pins. We test also the Raspberry with setting some stuff in order to see if it works. Then we set the subscribe and so on. Everything's here. We set the button callback. An important point is that we had to use thread to launch the publish actuator status. So in this case, this is the class that we have here, for example, publish actuator status, because every one of these methods present a cycle, and if we do this in the main thread, we block it. So we need to launch different threads so we can start it and then enable the main loop in the main thread.
In the middleware, one of the most important components is the catalog, and in our case, the gym catalog is the class that is able to merge together both the resource catalog and the service catalog, which are implemented as dictionaries and refreshed every time a microservice is going to register something. Among the other dictionaries that are stored inside the catalog, there are the configuration settings, which are generic information like database credentials that are stored like in a database and given to the service when they request for them in order to operate well, because they need it. The authentication dictionary, which stores the correspondence between the token and the microservice, and that is used to check that microservice has the rights to access for some functionalities. And the hostname usages, which is the solution that we use to give microservice global unique ID. In practice, the catalog is a server, so in order to interact with it, we need to use REST APIs. Among the GET requests you can do, there is the ping, which is just to check the status, the entry point, which is a kind of login of the microservice in the system. In fact, after the entry point, it has assigned an authentication token, and it is possible to retrieve the configuration settings that are asked to the catalog. The contrary of this method is the disconnection, DC, where the token is destroyed and everything related to the microservice is simply forgotten. So everything it has registered disappears and the state is updated for the system. The last GET requests you can have are about information retrieval. So the information about services that are available in the system, which can be a list, complete or filtered among certain criteria, and also a lookup. Given a service ID, you can retrieve all the information associated to it. This applies also for resources. And in case of resources, the filters you can apply are more, because in fact you can filter the list of resources by type of the request, you can filter by MQTT topic, but also you can filter by category or by device owner, which is the device that exposed them. So for instance, you can retrieve all the resources that are exposed in a given device inside the gym. Considering the post requests, we consider everything that is related to the registration, so both services and resources registration inside the system. The methods receives in practice some JSON code, which is the configuration description of the resource or the service that we are taking into account. And if the JSON is well formatted, the resource or the service is registered inside the system, considered as alive, and a success message is returned to the microservice. In order to start the catalog, you have to call a static method, which is run, that allows you to choose the port and the base path on which every URI will be called. So what happens is that a cherry pie server is instantiated, the stop method is the contrary, allows you to stop. And in order to see how it works, we can run this example that is going to instantiate a cherry pie server, wait a little bit, ping the server to verify it is active, and then stop it. Inside the core folder of the SmartGym package, there is the process launcher, which is a class that, using the functionalities offered by the multiprocessing Python class, allows the user to easily launch a generic Python method. You pass the target, which is the function to call, the arguments, and you give it as an ID, so that the same process is never launched twice. This is a design implementation, you have to think about it in advance. What is provided to the user, by the way, is a set of functionalities to work with the catalog and the MQTT broker. There is in the end an utility, which is a stop all, that allows the user to stop every process that has been launched. This is an example of a running process launcher. What we are doing is to define on the fly two microservice classes with just some hello world test messages, and after launching the broker, the catalog, and the two microservices, after 5 seconds of activity, everything is stopped. Let us now consider the database class. Inside this file you can have the code that allow microservices to communicate with databases, and actually you can work with two types of databases, which are the SQLite and MySQL one. This is possible because they share a same base class, which is this, that given some credentials to access, allows you to connect to a database, to close the connection, to import an existing database from file, to perform generic queries or statements if you want to pass some parameters and protect against SQL injection. And there are also some utilities like what is the last ID I've inserted with my rows, or what is the number of rows that I have worked with executing a query or a statement. You can also decide to work with transactions in a manual mode, so that you can commit and roll back manually all the operations that you have performed so far. This is the class that allows you to work with SQLite databases, while this one is the one that allows you to work with MySQL ones. Here, an example of running database connector, where a simple select query from the table user is performed. Because of requirements of coherence and service availability, also after new feature integration for instance, we decided to set up a fully automated test environment, and this has been possible thanks to the nostests library in Python. In fact, running the nostests command from the terminal, you can launch the entire set of tests and be sure that everything is running. Tests are available inside the test folder, and whose subfolders are the category of test you're going to perform. Every file is a Python file written in a certain way that actually model a specific class. So for every class we have a file, for every file we have test use cases, and for each use cases relative tests are implemented. Here, for instance, you can see the tests for the catalog class. Here you have the service registration, and everything related to that is checked properly, and everything happens automatically. The only side effect for that is the fact that writing test is long, because catalog test, for example, is a file that is 800 lines of code. But the advantage that it takes is enormous, because every time you introduce something new, every time you modify something existing, you are sure that the previous code is not tampered and everything is still working. Login activity is a must for every software product, and for that reason we create our logger for SmartGym using the Splunk engine. Splunk is a software that is used in context of big data analytics, and it's one of the most famous, most performance solution you can find today on the market. The way it works is that through the code we are calling these log methods that, given some fields, create a JSON text, send them to the Splunk engine, and creates an event that the user can see and can work on using Splunk dashboards, which are the graphic tools that, implementing as a web page, allows the user to analyze the data. We will see it in action. What you need to know about the code is that there are 4 types of Splunk events. Log activity, which are the info, error, warning messages. MQTT event, so all the messages that pass through the broker. Statistics, which are something we want to keep track through time, and the heartbeat of the services. The method that realized the Splunk integration is this one, and it simply calls a thread that connects to the Splunk engine, sending him the JSON code. We are now going to see the 4 dashboards that I've implemented in Splunk. The first one refers to log activity, so the events about the bug, info, errors that have arisen while executing the code. The second one is the MQTT dashboard, which gives an overview about all the MQTT messages that are sent through the network. We have then the statistic dashboards, which shows key information that we want to track and monitor through time. And finally, we have the microservice availability, which is a dashboard created starting from the heartbeat events, which highlights which are the services that have been active in a given time period and which are active right now in the last 30 seconds. Here is the Splunk dashboard in action. Because those tests are running in background, the code is running and is logging some events. As you can see, new events are captured and the content of the dashboard is refreshed because of the real-time search with 3 minutes time interval.
So now we have some demo using our Raspberry Pi and the sensors, which are that will interact with our system. So we have set some bash in order to see what is happening. We have launched Eclipse, Mosquito, and MySQL into Docker containers, and they are reachable through this port, and all the systems are using that for the connection part. Here it's possible to see some information coming from the catalog, which now is down. So we have the registered microservices, the resource catalog entries, and as well as the ping. Here we will have a subscriber that we can start, and we'll collect all the topics coming from SmartGym, so it's possible to see in real time what is happening. We have also Splunk, but we'll show it later. Okay, so here we use this for text, and here for launching the service catalog. So now we can start with the device connector. Okay, the device connector cannot reach the catalog. So now we have to start the catalog before. So let's start it. Okay, took a while. Okay, the catalog started, and okay, it retried the connection, and as you can see now, okay, we have the initialization of the of our Raspberry Pi with all the sensors. So the system now is running, and it's running with just the catalog and the Raspberry Pi. Now we show some demonstration of the different modules, starting from the facility manager. But before this, as you can see here, we have some information coming from the catalog. For example, the resources registered by the device connector, as well as the fact that the device connector is registered. So we have this statefulness between the catalog and the microservices. So now we can start the module, the microservices. Okay, the facility manager is up. It doesn't register resource because the only one is the device connector. The catalog is still up, and okay, I didn't comment this, but basically we are receiving some information. We have only the shower, okay, because the only active module for now is the shower. But here we can see that we have all the read from the sensor attached in the Raspberry Pi. So now we can try to simulate a user scenario. Okay, now we simulate a user that wants to have a shower. So we have the sensor presence that now is enabled. So the user can use the NFSC for interacting with the shower and activate it. Please, Giorgio. Now, for demonstration purpose, we enable it only for 5 seconds. Okay, so the shower ends, so the user has to use again the NFSC to enable it. So again. but now the user decided to leave. As soon as the user leaves the shower stops in order to save water. So this is just a way to enable a smart behavior of the shower. As you can see, if the user comes back, nothing happens. So the user can have another shower. And again, if it leaves before the end, the shower stops. Okay, so now another user, which is possible to set the credit to 0. So we can demonstrate that the user without credits cannot activate the shower. It's simulated using a publisher. So we publish the MQTT topic related with the NFC. So now we can see that we send this message, and it's possible to see it here, but nothing happens. And again, if we do it, we have the message has been sent, but nothing happens. But as soon as we set it to 1, for example, so we update the DB, try again, and now the user can have a shower.
So now let's have a look to the SmartGym website. This website has been thought as a service for the operators for a better user and schedule management, where we mean, for example, creation of a user with all its information, creation of a schedule with customized exercises based on the athlete's objective, and so on. But now let's see how it works. The website retrieves all its information performing HTTP requests to a microservice, which is able to obtain all the requested records from the database and send these as a JSON response to the website. In order to guarantee a higher level of security, in the initial request that the operator performs, so the login operation and the register operation, with the parameters that we send, so in this case, for example, email and password, we send also a cookie. In particular, this cookie called APD, as we can see also here. This cookie here is necessary because it identifies in a unique way the application that is performing the HTTP request, in this case the website. Okay, now let's see what happens. Here I'm performing a login operation. What we can see here is that we have now different new cookies, for example email, first name, last name, and so on. But the most important one is this one called token. This cookie called token is also in this case as APD an alphanumeric string composed of 25 characters, but this cookie here in this case identifies in a unique way the user that performed the operation of logging or register, that in this case is Matteo November. From now, these two cookies, APD and token, will be used for all the requests to the microservice in order to obtain all the necessary information, as we can see, for example, here. For example, creation of a user, create user. We have here the cookie, not only APD, but also cookie token. Okay, now let's see what are the services that are present inside the website. First of all, we have the management of user, so we have all the user, the address at the end that are present inside the system, for example this one, and we can read the name, the surname, email, and so on, subscription, typology of subscription, and the expiry date of this subscription. Obviously, we can modify its information, delete them, and also create a new user, obviously, and search by surname a specific user, for example, this one. And thanks to the autocomplete operation, clicking on it, and I look at this. Then we have the management of schedules. And what we can see here is again the all all the users that are present inside the system, but now what I can check is the schedules referred to this specific user, in particular Matteo Novembre. Here we have the name of the schedule, details, start date and so on. Then I can check also the exercises that are present inside this schedule. Here we have this exercise with the day at which this exercise has to be executed, repetition, weight, details, and so on. Then I can read also the exercise with the description and the muscular zone, and also a YouTube video for a clarification about the correct execution of the exercise. Obviously, all these information are also available for the user through the Android app. Then we have the push notification that are sent through the Google platform called Firebase. In particular, here we have, for example, this message, summer holidays, with its body, the date at which it has been sent, and the destination, that in this case is also it say that we are talking about a broadcast message. Then we have the dashboard, where we have the graphs taken by TeamSpeak about the temperature and the humidity inside the gym that are obtained by the Raspberry. Obviously, these two graphs are the same that we have inside TeamSpeak. And here we perform average, we compute the average of the temperature the current day, and also the average of the humidity of the current day. Okay, coming back to the home, if I want, for example, perform a logout operation, what I want to do is to perform also in this case a request to the microservice to log out, obviously. Once that I perform this operation, I wait for a successful response. So the microservice will delete the token and the user referred to this token from its dataset, and then send a successful response. Once that the website receives this successful response, then what we do is to delete all these cookies. Okay, the logout has been performed, and here, as we can see, we don't have anymore all the cookies. This way, if I want, for example, access to the website from another page, for example, this one for the management of the user, what is here, what the message that I obtain here is to do the login, because I have to obtain the credential to access to the different service. Okay, here I have APD, I have to obtain now the cookie token.
This is the SmartGym Android application that allows the customers of the gym to access their information about their status of the daily training. Also, they can see the notifications sent by the gym owners related to the schedule of the gym and the promotions they offer to their customers. Also, they can visualize their profile that they use to subscribe to the system, and then for each exercise of their schedule they can see all the details about the repetitions, the weight, and the informations about the way in which they have to perform the exercises. So this represents a valid and complete solution to help them throughout the daily training inside the gym. This application relies on a microservice communication, which is very similar to the one used for the web site one, and the definition of the routines and the procedures are similar to the ones that are used for the website. When the user will perform the login phase or the sign up phase, it will include in the request to the microservice a cookie which identifies the application called app ID that specifies that the application is valid and it can start the communication with the controller. Furthermore, as soon as it performs correctly the login phase and the sign up phase, the application will receive from the server a cookie which will be used in the future for accomplish all the possible HTTP requests in order to identify univocally the user inside the system, so that the system will fetch the information related to that specific user. In particular, when the user uses this application, it starts from the login page, from which he can decide to log in with existing credentials or to sign up to insert his new information and then to register to the application itself. If we push on sign up, we can see a registration form in which the user has to compile their fields. When instead the user wants to use their own existent credentials, it will log in inside the system. At this point, he can notice that he can see the schedules and the routines. If he has many of them, he can all see them inside this page by scrolling this view and then see the other routines. For each routine, we have many exercises that are fetched from the database stored in the controller, and for each of exercise, you can see the details, and also a web video will start from YouTube and it will explain the user how to perform an exercise.
Per terra, zona lombare leggermente inarcata, scapoli addotte per preservare l'articolazione delle spalle. Il movimento.
After that, you can touch on info button about the schedule to see more information about that routine. In particular, details, objective of the routine, and the duration of that routine. If the user plays the entire schedule, he will start the training of this routine, and then for each exercise we can have a chronometer that helps the user to count the time, and then he can also pause the time and restart the time if needs for its particular exercise. After that, you can go on and then you can start a new exercise till the end of each exercise. At this point, there is another part of the app, the notification part, which displays the information that are sent through Firebase cloud messaging. So you can see all the information about the promotions and the information sent by the gym owners. Eventually, you can also visualize its profile to see all the details used for the registration phase, and then see the subscription status. In particular, it can visualize if the subscription is expired or if it's still valid. At the end, when the user wants to log out from the application, he can tap the above button and decide to log out the application, and then a specific routine inside the microservice will discard the entry of that user in the logged users, and then he cannot access anymore unless it performs the login procedure.
Okay, now let's have a look to the database table. In particular, here we have 8 different tables. First of all, we see the account table, where are stored all the operators that can access to the website and perform all the different operations, so user management, exercise management, and so on. Here we have the ID account that obviously is the primary key with the auto increment index. First name, last name, email that is a unique index, and the password that is an encrypted password. Then we have the user, that are the athletes that are present inside the system. So also in this case the user primary key, name, surname, email, also in this case unique index, password unencrypted password, birth date, address, phone, subscription, typology of subscription, and date and subscription. The message, so here we store the message that are sent through the Google platform Firebase. In particular, first of all, we store the message inside the database, and only once that the website receives the successful response from the microservice and now then performs the message, the push notification through Firebase. Then we have schedule, so in this case we have the schedule that are present inside the system, that in this case, as we can see here, are referred to a specific user, in this case Matteo Novembre, as we can see here. Obviously, each schedule is characterized by the presence of different exercises that are stored in this table, exercise schedules, where we have that each of these exercises, for example, are referred to this specific schedule, that is that one that we saw before, that is that one that is referred to this user. And then we have the exercise that get the name of the exercise from the exercise table, where the exercise in this case is 3. The day, repetition, weight, and so on. Here we have in this last table the exercise that are present inside the system, so that is possible, the exercise that is possible to insert inside the schedules of the users. Okay, now let's see how the microservice used by the SmartGym website is structured. In particular, how it's possible to obtain the user information, the exercise information, and so on. As we can see, we defined a different method that at the end retrieve different information based on what the website is interested in. As we can see, for example, we have this method here, read one exercise, that perform a query into a database, into a table exercise, in order to obtain all the information about a specific exercise. Once the query is performed through this customized method, dbPerform query, if the response is none, it means that there is no record with this ID, so JSON with status equal to not found, as we can see here, is sent to the website. Otherwise, a JSON is structured, and then this JSON is sent back to the website. The same principle we can say is valid for all the other method. So perform the query and structure JSON as a response. And at the end of this method, we can see this endpoint. Endpoint, that is a dictionary where we say that for this specific endpoint, so manage read one exercise, we are referring to this specific method. Now let's see how the login operation works. And the first very check that is done here is calling this method here, out app. This method in particular checks if the value of the cookie APD is valid, so that the application that is performing the login request is an allowed application, so that can access to all the services that the microservice provides. Once that this check has been done, we perform the usual query. So we check a record with this email inside the DB. Then once that this record has been found, we check the password that has been done by the operators, and then if everything is okay, we create a JSON as a response, and also we set this cookie called token. Okay, the same principle is valid also for register account. So we have also in this case the cookie token as a response, while for all the other method, as we can see, we have a different check method that is called out. This method in particular checks both the value of the cookies APD and token. So in order to understand if the application that is performing the specific request is both valid and registered. Okay, so now let's have a look to the Telegram bot of the SmartGym system and on how it is structured. On the left side, we can see the default interface of Telegram with a very short description what this bot can do, so provide information about the actual temperature and humidity inside the gym, but also average values of these two. While on the right side we have the Telegram bot that also in this case is structured as a microservice. In particular, what we want to obtain by the registration, performing the registration to the catalog is these values, token, channel ID, and API keys that are parameters necessary in order to establish a correct connection with the Telegram APIs. Obviously, the registration to the catalog is supported by this configuration file here, where as usual we declare the IP address, the server port, the configuration settings, and the exposed services, so the service that the Telegram bot can provide, so get temperature, get humidity, and so on. Here we have the values of the token, of the channel ID, and API key. Okay, now let's start the microservice. And as usual, first of all, we start the catalog and then we start the microservice. So we retrieve all this information here and we set up the bot here in the logic application. Here we set up the bot, and then obviously we provide also a list of possible commands that the user can type, and obviously the response to this specific command. Let's see an example. Clicking on start, we receive a very short welcome message, and then we can also type on this button. Tap on this button, we obtain the list of possible commands, in particular get temperature, get humidity, that provide us the actual temperature and humidity present inside the gym, and also get today temperature and get today humidity, that is the average value of the temperature and humidity of the current day. For example, get temperature, I obtain this value, and get humidity, I obtain this value here. Then, for example, if I type a command that is not present inside the list, what I obtain is an error message where I'm notified about the fact that this command is not found, is not valid, so I can click on help and obtain the list of all the possible and available commands for the Telegram bot.